All right, hey everyone, welcome to the webinar. Thank you for joining us. So this session today is about our EV charging solutions, focusing on the newest addition to that family, which is the Wattpilot Flex. For those of you that don't know me, my name's Pat. I look after the training side of things at Fronius, and I'll be taking you through this whole session. All right, so what's on the agenda today? Firstly, we'll look at which Wattpilots are currently available in Australia and New Zealand. We'll look at an overview of the Wattpilot Flex and the new features that it brings compared to its predecessor, the Wattpilot. We'll cover some of the installation considerations very briefly, then look at the functionality of the Wattpilot and what it can do in terms of smart energy management. Lastly, we'll look at how the Wattpilot can be monitored in a solar system. Okay, so this is the 2026 portfolio as it stands. So as you can see up here, the Flex will essentially replace the Wattpilot Home. We still have the Wattpilot Go, which is the portable model, because the Flex doesn't come in a portable model. So that comes with a 3-phase 32 amp plug on the end. As you can see, both of these models are 22 kilowatt models. So we won't be bringing in an 11 kilowatt model anymore. And you can see that I've written 32 amps next to both of those. Why? Because it's better to think of them as a 32 amp model compared to it being a 22 kilowatt model, because how fast a EV will charge is dependent on a few factors, right? So a lot of them only have 11 kilowatt onboard chargers for one. So you wouldn't be getting that full 22 kilowatts. But in Australia and New Zealand, a lot of properties are single phase properties. That means with a 32 amp charger, you could charge with around 7.3 kilowatts on a single phase property, which again is not quite that 22 kilowatts. Now, if you had the 16 amp model that we used to bring in, the 11 kilowatt model, you'd be doing half of that. So, 3.6 something kilowatts. So it was used mainly for very niche scenarios, but we think that the 22 kilowatt or 32 amp model is much more suitable. As you can see there, all Wattpilot variants work on both single phase and 3-phase sites. So they're able to phase switch. And this is an important feature, which I'll touch on later as well. All right, so looking at the Wattpilot Flex Home, unlike the Wattpilot Go, the Flex comes with its own Type 2 charging cable, so that's tethered to the unit, and it's 6 meters in length. It also has a new display and user interface, and I'll show you that in a bit more detail later on. Then on top of the Wi-Fi connection that the Wattpilot Go has, or the predecessor of the Wattpilot Flex has, you now also have a LAN connection. So that was based on feedback we got from installers that they prefer to have LAN, and having a hardwired connection also makes it more of a secure connection. So we've included that in. And there's also flexible cable entry options. So before, the Wattpilot used to have a cable going out the top, which you would wire in. Now you can actually bring in your cable from the back, bottom, or top. And I'll show you that in a later slide. The Flex also has an improved temperature and IP rating, so allowing for even greater performance in a wider range of temperatures. And the new IP rating makes it even more protected against dust and water. It also has an upgraded, faster computer, right? So because of that, as new features come along, we'll be able to adapt to those and incorporate them in. So it's essentially like future-proofing the product. Also, as part of that, in terms of what we've done to future-proof, is include a dedicated communication chip designed for ISO 15118. So this relates to a communication standard which would allow, amongst other things, chargers and electric vehicles to digitally talk to each other. Now, right now, this functionality is not yet active on the Wattpilot Flex, but the hardware is already in the unit, which keeps the door open for future capabilities and firmware updates as the product and the industry as a whole matures. Now, such capabilities include the hot topic of bi-directional charging. Now, just note, this chip currently has no firmware on it at all. What it would be used for is still an open question. Why is that the case? Currently, there's no EV on the Australian market or the New Zealand market that can do bi-directional AC charging, and we don't know when we will see one. That could be several years away for all we know. Now, by the time it is possible, there could be different standards, regulations in place, which may have different rules, which we have no idea about. So what we've done is put this chip in so that we have the hardware that could allow us to incorporate more features in the future, like bi-directional charging, but it's still an open question. Okay, so just keep that in mind. Looking at the Wattpilot Go, so as I said, it comes with an integrated 32 amp 3-phase 5-pin plug on the end. Now, if you want to use it on a single phase property, you just need to make up an adapter lead. So essentially you'll have a 32 amp 5-pin socket and then a 32 amp 3-pin plug. And then you need to install a 32 amp single phase 3-pin socket outlet for that to plug into on the wall. So that's how you'd adapt it. One of the questions I get from time to time is about using a Wattpilot with a third-party inverter. So yes, it is possible. The easiest and most cost-effective way, I would say, is to incorporate a smart meter IP. So with that, you can utilize PV surplus functions. You can also utilize dynamic load balancing functions, and I'll cover that later on. Another way you could do it is use any Fronius smart meter paired with a data manager box. So that's essentially the same monitoring card that used to be in our snap inverters in a box. So that will communicate with the Wattpilot. You can also use a catch power device, or you can use some third-party software providers like ChargeHQ. Just note that ChargeHQ has ongoing subscription costs if you were to go down that route. Now, if you are looking to install a smart meter IP and a Wattpilot, reach out to our team and we can send out more instructions on how this is actually set up. But essentially, the IP meter and the Wattpilot need to be on the same network, and then you'll go and configure it in the Wattpilot settings. Okay, so looking at some of the features and functions of the Wattpilot Flex. So first off, it includes a very slim and elegant design. So you can see the dimensions there. So it has a really nice premium look when installed. Then you can see the display and interface there, a bit more detail here. So you've got your LED ring, which essentially shows you where the energy is coming from. So the ring colors will match where the power is coming from. So silver means from the grid, green from battery, and yellow from solar. And if you go into the app, it will match what the user is going to be seeing in the app as well. Then you've got some buttons here, which will allow you to change between the different charging modes. So I'll cover that in a bit more detail later. So essentially you've got standard charging mode, your eco mode, and next trip mode. So eco mode here in Australia and New Zealand is basically PV surplus mode. And then you can see what power, or energy, so kilowatt or kilowatt hours is displayed on the front, right, in actual real time. And then you've got your RFID spot here. So you can use an RFID fob or tag, which can be really useful if you're installing the Wattpilot in a public area, such as a hotel or Airbnb or something like that. So just looking at how the cables are brought in, as I said, you could bring it in from the bottom, the top, or from the back. So yeah, it also adds to that how the Wattpilot looks as well, and why it's got that nice, elegant design. So you can really hide your cables if you want at the back. Looking at some of the different charging modes and features. So this is the standard or easy charging mode where you can charge with a preset current. So you can set 5 different levels. As you can see there, maximum being 32 amps, this 32 amp charger. And you set those 5 levels in the Solar Wattpilot app and then switch between those levels using the app. On the Wattpilot Go, there's a button on the front, which also allows you to switch between the different current levels. But on the Flex, you'll do that via the app. The scheduler function essentially allows you to allow or block charging for 2 defined time periods, which you can do on weekdays, Saturdays, or Sundays, and you just toggle between those 2 and put in your different blocks. So the advantage there is that you can take advantage of cheaper electricity rates or avoid charging with more expensive electricity rates, okay? PV surplus charging. So as I said, if you select eco mode, it is basically the same as PV surplus charging. So this is controlled in 1 amp steps. You can't see all the steps here. We've condensed the table so that it fits on the slide, but essentially that would be going up in 1 amp steps. So very fine control of how much surplus PV is going in. So it'll start off on single phase. If you're on a 3-phase property, it'll start off on single phase, and it'll start off at 6 amps, which is roughly 1.38 kilowatts. So that 6 amp minimum is dictated by regulations for EV charging infrastructure. So it's referenced in IEC 61851. Basically, 6 amps is the minimum permissible charging current for AC charging for home and public EV chargers. So it starts off at 6 amps, 1.38 kilowatts. And then as it gets to somewhere around 18 amps, it'll switch over to 3-phase and then be charging on 3-phase power. Now, other chargers which can't phase switch, if they're used on a 3-phase property, they would essentially be starting at 4.14 kilowatts, right, at that 6 amp minimum. Because we can phase switch between single phase and 3-phase, it means that you can start at a lower power, and it means that you're going to be allowing for using more surplus power and diverting that into the EV. So you're essentially able to get more out of your solar system that way. Next, trip mode. So this is where you've got a specific trip that you're going to be going on. So say, for those of you in Melbourne, you might be going down to Geelong in the morning, and you know that when you reach your destination, in our case Geelong, you're going to be able to charge for free or for a very low cost. So you want to charge the EV only just enough to reach the destination. So what you can do is, depending on the car that you've got, you can set the car's consumption per 100 kilometers. And then you want to set the minimum amount of charging. So you can do that in kilometers or kilowatt hours. And then what time you want it to finish by. So here it's 6 a.m. And then essentially it'll charge, you know, making sure that it finishes by 6 a.m. and giving you just enough to reach that destination. The next one is dynamic load balancing. So this feature is really important when you have multiple Wattpilots on the same site to make sure you don't overload the connection point or supply line. It's also important even if you just have one Wattpilot on site. So if you have loads with, you know, a high draw and you've got your Wattpilot there, which potentially could be taking a lot of amperage as well, you want to make sure that you're not tripping that breaker at the main connection point. Technically, an unlimited number of Wattpilots can be used with the dynamic load balancing function. And essentially what will happen is, whether it's one Wattpilot or multiple Wattpilots, it's going to dynamically ramp up and down the Wattpilot or Wattpilots, depending on how much current is available. And that's taking into account how much solar is available and also how much the loads on site, whatever it is, you know, lights, fridges, air conditioning, heater, whatever you've got going on is also using, okay? So the requirements for setting this up, you need to have a smart meter on site, just like with the using surplus solar, there needs to be a smart meter there as well to know when there is surplus solar. All of the Wattpilots need to be connected to the internet if you've got multiple ones there, because essentially a part of the solution is that the dynamic load balancing runs off the cloud platform. And then all the Wattpilots on site, or the Wattpilot on site, needs to be paired to the same device. So typically that's an inverter's monitoring card. So, you know, the pilot monitoring card, which is in GEN24s, Toro or Verto inverters, or the data manager card, which is in our Snap inverters. So all the Wattpilots, if there's multiple ones on site, will be paired individually to this same device. Then the Wattpilots, for that to happen, you need to have it on the same local network as the device it's being paired to. So looking at how you exactly set this up, so you've got the maximum delivery current. So that's looking at the distribution board that the Wattpilots are connected to. So this allows the Wattpilots to ramp up and ramp down without tripping the breaker on that board. The max supply line current, that's looking at the whole site. So that's, you know, what your main switch will be rated to, or your whole site's rated to. So that's allowing the Wattpilots to ramp up and down without tripping the breaker up there, okay? And that's based on the import, export of the entire site. You can also see an option here for phase assignment. So many EVs will have single phase onboard chargers. So if you have multiple Wattpilots and they're all trying to charge at once, it could mean that there's a lot of power being taken from line one, say if you're on a three-phase site. So this would then cause all the Wattpilots to ramp down to essentially make sure that it doesn't trip that breaker. So what you can do is connect line one of the Wattpilot to different phases on the site. So essentially spreading the Wattpilots out. But then you need to tell the Wattpilot which phase you've connected to. So that's what that phase assignment is about. So you can select the phase assignment and say my Wattpilot is connected to L2, L3, L1, and the system will take this into consideration because a smart meter will be seeing L1, L2, L3. Okay, so it'll take that into consideration depending on what you've put in there. Lastly, you can set priorities. So this is if you have multiple Wattpilots on site. So there's 3 levels you can select, which is low, medium, or high. So essentially the highest priority Wattpilot is going to get the most amount of current. And then any leftover will go to the next priority and so forth. If they're all on the same priority, then they would get an equal split of their available current. So that's how that works. So the Wattpilot constitutes one part of the Fronius ecosystem. So in a full Fronius ecosystem, you might have a hybrid inverter such as the Verto Plus or the Gen24 Plus, and a compatible DC coupled battery like the Fronius Reserva. Then you might have an ohm pilot on site. So the Fronius ohm pilot is used for diverting solar power into a hot water system, for example. Another resistive heating element can be used for underfloor heating and things like this. And then you could have the Wattpilot as well. So essentially with the ohm pilot and the Wattpilot, you're able to sector couple the Fronius inverter with these heating sectors and the mobility sector. Right now, having everything in the same ecosystem allows for more control over each component. So here, as you can see, you can set priorities for your own pilot, Wattpilot, and DC coupled battery. There's some load management priorities as well that come into place. That's in the inverters web UI. So you can select your priority for battery, own pilot, or the load management function, which I won't go into today. But here, if you've selected battery and own pilot, then when you look at doing any controls in the Solar.wattpilot app, which is over here, then it's going to look at the battery first and then the own pilot. Right. So here in the Solar.wattpilot app, what you can do is put in settings to designate how your surplus PV power is being used. So what you can see here is that the system has it set so that the battery is going to be charged to 70%. The hot water should be sitting at 40 degrees Celsius. And then only after those conditions are met will the system allow surplus PV power to be put into the Wattpilot to charge the EV. Now, these can be changed remotely via the Solar.wattpilot app. So you can put lower thresholds there if you wanted the Wattpilot to get power more quickly to put into the car. So that's just some of the controls that you have. And we're always looking to improve the functionality that we have for our end users as well. So there's various updates that we're planning for Solar.web and also for our other applications as well. If you have any questions about these functions or setting them up, please reach out to us. You can give one of our state managers a call or an email, or you can reach out to myself. Lastly, looking at how the monitoring side of things works. So like our previous versions of the Wattpilot, everything can be monitored in Solar.web. So here on the dashboard of Solar.web, you can see what's happening in real time. If you click on the load symbol, so it's that blue plug point symbol, you can see what's going into the Wattpilot in real time. And then if you go into the energy balance tab from the dashboard, then you can see historical data. And the Wattpilot is shown there in purple. So this is the daily view. And then you can go into the monthly, yearly, or total views, which will give you a bar graph. And then you can see the daily totals or the monthly totals or the yearly totals, depending on the view that you're in. Okay. And then you can also see, say, for example, the own pilot, if there's one on site, or battery, if there's one on site as well. So the full ecosystem, as I was talking about before, is visually represented there. You can get a lot of data. Lastly, in the analysis tab, if you go into history, you can get more detailed data like voltage per phase, current per phase, etc. So, you know, depending on what you need to look at, or if you need to do some troubleshooting, etc., you can go into there and get quite a lot of detailed info. All right, that brings us to the end of the webinar. So if you have any questions, please put them into the chat box and I will endeavor to answer as many of them as I can. G'day, Stavros. Stavros had asked about DC charging and whether that's on the cards for the future. So yes, DC charging is something that our R&D team is looking at, and I have no idea on timelines for development, but I do know that they are looking at that and trying to develop something there. Dean had asked about whether, sorry, I've just lost the question there. So yeah, whether it needs to be a smart meter IP or if it can be any Fronius smart meter. So Dean, if you use it, it doesn't need to be the smart meter IP to answer your question simply. But if you're using the smart meter IP, it doesn't need a data manager box to connect to, right? It can communicate over the network itself to the Wattpilot. Whereas if it's any other smart meter, then it needs to be connected to a data manager box if there's no inverter on site. Otherwise, it'd be connected to the inverter, okay? But essentially, you need something to be able to communicate with the Wattpilot. So the smart meter IB can do that by itself. Other smart meters will need either a data manager box or an inverter to do that. Hi, George. Welcome. Yes, you've asked about the improved temperature range and IP rating. I don't have the exact specs of the temperature rating off the top of my head, but I can come back to you on that one. The IP rating is now IP66. And it used to be 55, I believe. I can double check that for you. But essentially, you're going to have better dust and water protection that way. Kane has asked about the changes coming to Solar.web. So essentially, over the next year and a bit, there's going to be multiple stages of updating the Solar.web interface, what that looks like, and the usability of it and the functions that are there. So there's going to be some changes in terms of how Solar.web looks for an end user and how it looks for an installer as well. So yeah, there's going to be different functionality for installers and end users. I can send you a little bit more detail in terms of what those things might look like, but it's still a work in progress, but there's various things that they're trying to improve. And one of those things being that they want to have different functionalities for installers and end users because they're using Solar.web for different things. Someone asked about whether they need to change the smart meter to an IP meter on an existing Gen24 and BYD site. No, I don't know why you need to do that. If there'd already be a smart meter on that site because there's a Gen24 and a battery, so you need that for battery functionality. And there's no reason why you need to replace that smart meter with an IP meter. The IP meter comes in handy for two reasons. One, that it can communicate wirelessly. So our other meters that we currently have available can't communicate wirelessly. So they need to be at least natively anyway, without any third-party device. But usually what you'd be doing is wiring your smart meter to the inverter physically. That's a Modbus RTU connection. The smart meter IP can communicate wirelessly over a network using Modbus TCP or MQTT. So yeah, you don't need to use an IP meter unless you're going to be using it wirelessly, or if you've got a Wattpilot on site and you don't have an inverter, a Fronius inverter, I mean, then you could use a smart meter IP there. But otherwise, I would actually just use one of the other meters because it'll be more cost efficient. Sharif had asked about where you can purchase the Wattpilot Flex in WA. So Sharif, we have a number of authorized sales partners that you can purchase this from. I'm assuming you're an installer, so then you'd be able to purchase from one of our authorized sales partners. So that includes Kranick, Baywa, Solar Gain Wholesale, Solar Juice, supply partners. So yeah, any of those. George, no, I don't think you will be able to utilize that LAN 2 port. So you'd asked about connecting the Wattpilot to the LAN 2 port. That should have been removed, I think, in the latest iterations anyway of the Gen24. But no, essentially you'll connect it to the same router, the Wattpilot and your inverter, and then they'll communicate that way. Neil had asked about telling the Wattpilot not to discharge into a battery. So there are some controllers you can put around this, Neil. I'll send you some more information on how that can be done. But there are some limitations to that as well. But there's no setting in a way on the Solar.wattpilot app. George, you've asked about the release date for the Flex Pro. Currently, that's not planned for Australia or New Zealand. That may change, but yeah, currently we just have the Flex, which is the grey version, as you saw in the presentation. That's what's here already and is being brought in. All right, looks like no other questions are coming in. I will go through all these questions, and if I missed any, I will come back to you. But otherwise, if you have any further questions, feel free to reach out to the relevant state manager that's in your region, or you can reach out to us at pv-solutions-australia@fronius.com. Thanks for joining, and I'll see you next time. See you guys. Bye.